Assalamu alaikum, this is Asif Raja. Today's our problem is the 15 lb cylindrical collar is released from rest in the position shown and drops onto the spring. Calculate the velocity v of the cylinder when the spring has been compressed 2 inch. So our body of interest is when this column compress the spring 2 inch. Then we find the velocity. First of all, go the formulas to see which we used in this numerical. The work energy relationship of a particle, initial kinetic energy plus work done by the column and the spring, is equal to the final kinetic energy. And for the spring, work done of spring, the equation is given like this. The x1 show the distance when spring is not compressed, and x2 shows when spring is compressed. Like in this problem, x1 is equal to 0 and x2 is equal to 2 inch. Let us go to see the equation and find the data. So our data is total displacement, which we get 18 inch, and when spring compressed 2 inch, then we add both and we get 20 inch. In this question, the gravity is given is 32.2 foot per second square. That's why we need to convert all the values which are in inches to foot. Okay, by conversion we convert the total displacement into the foot and x2 into the foot, k is also into the foot, and mass is equal F over g. So we go our problem solution simply using the work done by spring. So by putting the values in this, we get the work done by the spring, which is negative. It shows the magnitude is negative, not the work done. Okay, now we find the work done by the column. By force multiplied by total displacement, we get 24 pound-foot. Okay, by this formula we would add the work done values. By adding values and the final kinetic energy, in this question initial kinetic energy is 0. So by putting values we get the value of velocity when spring is compressed 2 inch.